Our next main topic is going to be the binomial theorem. Very important in probability or combinatorics, anything where you're required to do a lot of counting. And before we get to the binomial theorem, though, we're going to have to introduce the binomial coefficient. And to introduce it, let's make sure we remember what n factorial is. N factorial for a positive integer, or it could be 0. We define 0 factorial to be 1. For integers greater than 0, it's simply the product of all of the integers from 1 to n. N factorial is the product of all the integers from 1 to n. We generally write it backwards like this. So n factorial, n times n minus 1, go all the way down to 1. Well, suppose you're asked, or maybe you're in the situation, you had 6 people in a room and 1 chessboard, only enough time to play 1 game of chess. You have to choose 6 people. Among the 6 people, you have to choose 2 to play that game of chess. How many different ways are there that you could choose those 2 people? Now remember, if you choose person A and person B, order doesn't matter. So if you choose A and B, that's the same as choosing B and A. It's the same 2 people. So let's just figure it out the hard way. Let's say you've got A, B, C, D, E, and F. I could write them all out, and maybe I will, because it's not too great of a number. But AB, I should probably write it like A, comma, B as a set, but AB means I chose A and B. So the nice ordered way to do it would be, let's get all of the possibilities where A is included. So I could go AB, AC, AD, AE, AF. Now I've completely taken care of A. So now let's go to B. Let's get every pair that has to do with B. I'll start at B, but I don't have to go backwards. I don't have to go BA because we already did AB. So all I need to do is go BC, BD, BE, BF. Let's go to C. Now I've already done everything with A and B. CA and CB are both done. So the first one I'm going to do is CD, then CE, CF. Then I'll do DE, DF. And then the last one is just EF. That wasn't too bad. Nice, ordered, systematic way of doing it. We included every possibility. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, great. So what I'm going to talk about next, maybe I'll give you a preview. 6. This terminology, this symbol, the parentheses, no fraction bar, this is 6 choose 2. That means you've got 6 people in a room. How many ways can you choose 2 of them? And we know now that that is 15. But if that were 100 choose 2 or 1,000 choose 2, we would not want to write all of this out. It would take forever. So we're going to look now at the formula that would give us this answer for no matter what this top number and the bottom number are. And this is where we come into the binomial coefficient. 4. N and R being integers, and they're not going to be negative because we're going to say that. They're integers. R is at least 0, and N is at least as big as R. So first, let's define just the kind of the terminology. N choose this symbol is N choose R. That's just the terminology we use. You can use a longer terminology. You can say this is the combination of N things taken R at a time. In our previous example, it would be the combination of 6 people taken 2 at a time. and it's a number, where n choose r is equal to this, n factorial over n minus r factorial. That's the formula. Just memorize it. It works every time. So let's and I guess I should have written definition here. We just defined this term. And for our other case, n was 6. I'm done with the definition, by the way. R was 2. So how many ways can you choose two things out of a group of 6? Well, the formula says that 6 choose 2 is 6 factorial, because that's n. N is 6 and r is 2, over 6 minus 2 factorial times 2 factorial. And then this can be written 6 factorial over 4 factorial, 2 factorial. And just as a sanity check, after you write this out, to make sure you didn't do any arithmetic problems, make sure that these two numbers on the bottom that are taking the factorial of add up to the one that you're taking the factorial of on top. 2 plus 4 equals 6. And that is because r plus n minus r is equal to n. And now the beauty of factorials is, let me write this down here, is that they cancel very nicely when you have fractions. Just as a note, let's ignore the 2 factorial for a minute. 6 factorial over 4 factorial is just 6 times 5. Because this can be written 6 times 5 times 4 all the way down to 1, or in other words, 4 factorial, over 4 factorial. Anything over itself is equal to 1. 4 factorial over 4 factorial is 1. That cancels and gives us 6 times 5, which is 30. So what I end up with, simplifying here, I get 6 times 5, and then I'm canceling with the 4 factorial. So I did a lot of simplifying right there. The 6 factorial over 4 factorial just became 6 times 5. And 2 factorial is just 2. 2 times 1 is 2. So 3, this would be 15. Which is exactly what we counted when we did the problem previously. So memorize this formula. It's very important. Again, you'll see it in probability or if any class where you have combinatorics involved. Okay, let's do just a couple more examples. Let's just pick some numbers. Say 7, 3. 7, choose 3. So now you have 7 people in a room. I think of people and choosing people. 7 marbles in a bag. How many ways could you choose 3 of them out? So this is equal to, by the formula, n is 7 and r is 3. So it's 7 factorial over 7 minus 3 factorial, 3 factorial, which is 7 factorial over 4 factorial, 3 factorial, which is, well, the 7 factorial, I'll leave the 3 factorial where it is for the time being. 7 factorial over 4 factorial. 7 is 7 times 6 times 5 times 4 factorial, which would cancel with this 4 factorial. So on top, that leaves me 765. And what is 3 factorial? 3 factorial is 3 times 2 times 1. That's 6. So this 6 and that 6 cancel out and give me 7 times 5, which is 35. So 7 people in a room, and you need to choose 3 of them for some reason. There are 35 different ways to do it. One more example. $100, choose 98. And you might be thinking, oh my goodness, that's a terrible problem. It's going to be big numbers, a lot of arithmetic. It's trivial. N is 100 and R is 98. 100 factorial over 100 minus 98 factorial times 98 factorial. So we get 100 factorial over 2 factorial, 98 factorial. Well, let's cancel the biggest one on the bottom with the numerator, 100 factorial. What is, ignoring the, let me go ahead and put the 2 factorial there, which I know is just the number 2. What is 100 factorial over 98 factorial? It's just 100 times 98. 100 factorial is 100, 99, and then 98 times all the way down to 1, or 98 factorial, which we have right there in the denominator. So 100 times 99. So let's see, 2 factorial is just a 2. 100 over 2 is 50 times 99. All right, I'll let you multiply that out. So, roughly 5,000, right? If that were 100, I'd add 2 zeros, 5,000 minus 50. 4950. I think. Double check me on that. So anyways, it's simple to say, to compute, if you have 100 people in the room and you need 98 of them, that's how many different ways you could choose the 98 people. Okay. I will probably discuss this later, but I'm going to go ahead and say it since I have this problem written. What would this be? 100 people in a room, and I need to choose 2 of them. How many ways could I do that? This many. These 2 are equal, basically because 98 and 2 add up to 100. You can think of it this way. If I'm going to choose 98 people, how many am I leaving behind? 2. Every time I choose a different 98 people, I'm leaving 2 different people behind. So whether you're choosing 2 and putting them on this side and the 98 on this side, or you're putting the 98 on this side and the 2 on that side, you're going to be able to choose 98 people exactly the same number of ways you can choose 2 people. And check out the formula. N would be 100, R would be 2. Here's n factorial. This 98 factorial would be 100 minus 2. And this is the 2 factorial, which is this. So I might have written them in a different order, the denominator. I might have written 98 factorial, 2 factorial, but the order when you're multiplying doesn't matter. So this is, well, exactly equal to this. So 100 choose 97 is also equal to 100 choose 3. 100 choose 10 is the same as 100 choose 90. So if you choose 90, you're leaving 10 behind. And one more comment. 2 more, just baby comments. N choose 0 and N choose N. And actually, let's do 3 of them. N choose 1 and N choose N. These ones I basically just memorize. I don't think of the formula. Memorize this. N choose 0. How many ways can you choose 0 people? Just think of it as there's only one way to do it. You don't choose anybody. And if you plug it into the formula, it'll just work out. You get n factorial over n minus n factorial times n factorial. N minus n factorial is a 0 factorial, which is defined to be a 1, and n factorial over n factorial is just 1. So just memorize that. There's one way to choose 0 people from a group. Well, how many, without using the formula, How many ways do you think you could choose one person out of a group of n? Well, that's simple. There are n people. There's n way to choose one person. And then there's n people in a room. How many ways can you choose all of them? One way. You don't leave anybody behind. You just take them all. So that's equal to 1. It'd be worth writing the formulas out for those just to verify that you get one in and one for these 3 simple examples.